Okay, can everyone see and hear?
Yep.
Okay,
I
good.
can see.
Okay, good. And it should be recording this time, so we're good. All right, so this is a really great rule, the chain rule. It's the most powerful one you're going to learn. And we're going to learn it to find the derivative of functions that can be thought of as composite functions, but really we kind of, the big name for them would be power functions. If you look at it, you can see we've got a function raised to a power. And the chain rule says that if you want to find the derivative of y with respect to x, you can find that by using what we call the chain rule, by finding the derivative of y with respect to some variable u using a u substitution, which I'll show you, and then multiply that by the derivative of u with respect to x. So there's like this chain reaction, and you can, I remember when I was in high school, they kind of taught like the du's you can think of them as kind of canceling out and you're left with dy by dx. It's not really what happens, but that's kind of what they mean by the chain rule. So we're going to look at it with a u substitution, and then we're just going to look at it in general because we don't want to do a u substitution every time we do a question like this. But to introduce the rule, it's good. So if I look at this, y equals x squared plus 3 to the 5th, I could let u equal x squared plus 3. Which means that y would equal u to the 5th. Is everybody good with that? If I let u equal x squared plus 3, y would be u to the 5th in that case.
That, yep.
Makes sense? Okay. So if I find du by dx, so the derivative of u with respect to x, what would that be? So the derivative of this with respect to x.
U to the 5th is equal to x squared plus 3 to the 5th. On that.
Okay, so we're just looking, if u equals x squared plus 3, what's the derivative of u with respect to x?
I guess
2x?
it's just that.
Can we agree 2x? Does that make sense?
Oh.
The derivative of this with respect to x is 2x. Is that good for everybody?
Yeah, that makes sense.
U by dx. Okay, down here then, what about if I find dy by du, the derivative of y with respect to u? Can we agree that that would be 5u to the 4th?
Yep.
Okay, so now if we use the chain rule, so now for the chain rule, so it says that dy by dx is dy by du, which is 5u to the 4th, multiplied by du by dx, which is 2x. But u we've defined to be x squared plus 3, so I can rewrite 5u to the 4th as 5 times x squared plus 3 to the 4th times 2x. So that's using a u substitution, which we don't want to do every time. So now let's see what I think of the chain rule as. So for me, when I see a power function like y equals a function to a power, I find the derivative y prime or dy by dx, I'll say y prime, by doing what I first call the outer derivative. So that's kind of like using the power rule on a function. So I bring the 5 down times whatever the function is to the 4th. And I call that the outer derivative. And then I multiply that by the derivative of what's inside, or of the function I'm raising the power to. So that gets multiplied by the derivative of x squared plus 3, which is 2x. And I call that the inner derivative. So that's how the chain rule works. Outer derivative multiplied by inner derivative. And then you can always clean them up. For instance, in this one, that wouldn't be the answer in the back of the book. They'd take the 5, which is a monomial, and the 2x, which is also a monomial, and multiply them together. And then you would end up getting 10x times x squared plus 3 to the 4th as your derivative using the chain rule. So you can see how we can get more and more complex functions as we learn more rules. So this is the last derivative rule that we're going to learn, the chain rule. This afternoon, you'll learn how to combine it with the product rule, and then tomorrow morning, we'll combine it with the quotient rule.
Does the chain rule here work if, say, it's not a power, but just like any other function?
I'm not sure what you mean.
Like it's a, say if you have like a function, but it's being done like, I don't know, say you're finding it to raised, like, I don't know, like say you're not raising it to a power, but you're doing some other function to it. Like,
so for instance, if you just had like y equals x squared plus 3x, but to the power of 1, so you wouldn't really even need the brackets, you could still think of it as the chain rule. Yeah, because what you'd have then, John, would be this would be to the 1. So your y prime would be 1 times that to the 0 times the derivative of what's inside. And anything to the 0 is 1. So you'd still just end up with 2x plus 3.
or I guess I was thinking like not raising it to 1, but like raising it to, or like, I don't know, multiplying it by something, or
You're multiplying it by something, like it does work together with the product rule, but that's only if you have a power function as part of your product rule, which you're going to do this afternoon. We're going to do this afternoon.
Okay.
Okay. All right. So this morning we're going to focus on just the chain rule. So I don't know if Mr. Zalaviga got to a composite of functions or not, but you can think of the chain rule as how you derive or find the derivative of a composite function. How many people have seen that notation f composite g at x? Okay, so that little circle there means composite. And what it really means is f at g at x. Okay, so f is a function not just of x, but of g at x, which is kind of what, if we think of here, if f at x is x to the 5th and g at x is x squared plus 3, then f composite g at x is x squared plus 3 to the 5th, or f at g at x is x squared plus 3 to the 5th. Okay, it's another way of writing that. So if that's the case, then at h prime at x, this here represents the outer derivative. So f prime at g at x, that's the outer derivative. And then times the derivative of what's inside, g prime at x, which is the inner derivative. Okay, so it can be thought of as the outer derivative multiplied by the inner derivative. So that's what we're going to do. If f at x is x squared minus 4x to the 6th, f prime at x using the chain rule. So this is a power function, a function raised to a power. Bring down the 6. Recopy exactly what's inside to the 5th. And then we multiply by the derivative of what's inside, 2x minus 4. Okay, outer derivative by inner derivative. Any questions on that one? Okay, the next one, we have to first write it as a power function. So we want to rewrite it. So this is just y, not y prime. Y is x minus 5 to the 1/2. So y prime is going to be 1/2 times x minus 5 to the negative 1/2, and then times the inner derivative, which is just 1. The derivative of x minus 5 is just 1. Any questions on that part? Okay, who thinks they know how I would write that simplified? The answer in the back of the book way.
1/2 square root of x minus 5.
Correct. Okay, 1/2 square root of x minus 5. Okay. So C, already in the right form, so we can go straight to finding the derivative using the chain rule. So y prime is going to be, so the outer derivative is going to be 4 times 2x squared plus 3x minus 4 to the 3rd, multiplied by the derivative of what's inside, which is 4x plus 3. And that would be the answer in the back of the book. Sometimes they might have the factor 4x plus 3 before the 2x squared plus 3x minus 4 cubed, but I don't care which order you put those in. Okay, for D, it's not in the right format to take the derivative, so I first want to rewrite it. Anyone know how I would rewrite this one before I use the chain rule? What do you think?
Everything in the bracket to the power of -4.
Correct. So we want it as some function to a power, and that is exactly right. So now we would find f, so that's just f at x. F prime at x is going to be -4 times 3x squared minus 5x plus 1 to the, decrease the exponent by 1, so that's -5. And then times the derivative of what's inside, which is going to be 6x minus 5. But that's not going to be our back of the book answer. So that's going to have the -4 and the 6x minus 5 in the numerator, and the 3x squared minus 5x plus 1 to the +5 in the denominator. Okay, so for E, again, first step would be to rewrite it as a power function. So it's going to be y equals, sorry, I need a drink of water here. 2x squared plus 3 to the half. So that's just y rewritten. Now we want to find y prime. I'll do dy by dx for a change. dy by dx is 1/2 2x squared plus 3 to the -1/2 and then times the inner derivative. Derivative of 2x is just 2. Then notice that we can multiply these monomials together. And 1/2 times 2 is just 1. And then this is going to move to the denominator and become the root of 2x plus 3.
Ms. Northwood.
Why isn't it 4x?
It is, thank you. I forgot, I dropped the squared here, see, when I recopied it. Thanks, guys. So 4x times 1/2 is 2x. Should be on top. All right, so for f, first step would be to rewrite it as a power function. So g at x again, I'm going to rewrite it as 3x plus 4 to the negative 1/2. G prime at x. So bring down the exponent, negative 1/2 times 3x plus 4. Reduce the exponent by 1, so that's going to be to the negative 3 over 2. And then times the derivative of what's inside, which is 3. Again, I can multiply the negative 1/2 and the 3, but that's going to give me negative 3 over 2. So when I'm writing the simplified answer, the negative 3 is going to stay on top. The 2 is going to go to the bottom with the root of, in brackets, 3x plus 4 cubed. Any questions about that one? Okay. They're getting a little more tricky. Does anyone know for G how you would rewrite it first before we find the derivative? No? Okay, so we're going to leave the 2. We're going to bring the 3x squared minus 5 up, but the exponent's going to be to the negative 1/2. Does that make sense?
Yep.
Okay. All right, so y prime then. So a negative 1/2 times 2 is negative 1 times 3x squared minus 5 to the negative 3 over 2, and then multiplied by the derivative of what's inside, which is 6x. And then if you want to write that in simplified form, negative 1 times 6x is negative 6x. This is going to move to the denominator, so we can have a positive exponent and write it in radical form. So it's going to be the square root of, in brackets, 3x squared minus 5 cubed. Okay, and for h, first we're going to rewrite it again as x squared minus 5x to the 1/3. And now we're going to find the derivative. So outer derivative is going to be 1/3 times x squared minus 5x to the negative 2/3, multiplied by the inner derivative, which is 2x minus 5. And then in simplified form, the 1 times 2x minus 5, 2x minus 5 is going to be in the numerator. And then the 3 from 1/3 is going to be in the denominator, as well as this term, which I can rewrite as the third root of, in brackets, x squared minus 5x squared. Okay, any questions?
I'm wondering, at any point would we be able to just find the derivative directly from a radical?
Without using the chain rule?
Well, without turning it into a power, like for example, the square root of something, would be able to put it, the derivative of that as 1/2 square root that thing?
Like if you just find a pattern and know it, but you'd be using the chain rule really to do it.
Yes, yes.
Yes.
But like instead of like going for the step, I guess, where you write out that it's to a like 1/2 power, you could write, you know, do
Like
it with,
skipping steps?
I don't know.
Yeah, I feel like, yeah, like you could, first year university, second year university, you'll be skipping steps more, but actually derivative calculus, you'll actually probably only do in first year until you take differential equations, and then it changes, which it's really cool, but you'd still be using the chain rule, you just would be skipping steps, which I don't want you to do in grade 12.
Okay.
All right, so here's a question where now we're finding the slope of the tangent to the curve at a point. So first we need to find an expression for the slope of the tangent by finding the derivative. So y prime is going to be 1/2 times x minus 4 to the -1/2 times 1 as our inner derivative. And then if we want to simplify that, it's going to be 1/2 root x minus 4. And then if we want to find y prime at 13, y prime at 13 is going to be 1/2 times the root of 13 minus 4, which is 1/2 times the root of 9. Which is 1/, it's going to be 2 times 3, which is 6. But that means that the slope of the tangent is 1/6. And we have, oh, that's all we need. We don't need the equation this time. So we can just do therefore. The slope of the tangent to the curve y equals square root x minus 4 is 1/6 at the point 13, 3. And the next one, we're finding the equation of the tangent line this time. So again, first get the slope of the tangent, and then find the equation of the tangent line. So first I'm going to rewrite that as a power function. So y equals x cubed plus 1 to the half. Find y prime. Inner derivative is 3x squared. Simplify it a bit. So I'm going to get 3x squared on the top and 2 times the square root of x cubed plus 1 in the bottom. And then I need to find y prime at 2. So substitute in 2. Make sure when you find y prime at 2, you actually write y prime at 2. A couple of people yesterday were just writing y prime all the way down even after they'd substituted. Or they were writing y prime at 2 before they substituted 2 in. So just be careful of that communication-wise. So that's going to be 12 over 2 times the root of 8 plus 1. So that's going to be 12 over 6, which is 2. So m tangent is 2, and our point is 2, 1. So we can use y equals mx plus b. And put in 1 for y, 2 for m, 2 for x, and find b. And we get b to be -3. So therefore, the equation of the tangent line is y equals 2, because that's the slope, x minus 3 to the curve y equals the square root of x cubed plus 1 at the point 2, 1. Any questions about that one? All right, now we're doing some fun ones. Okay, so notice how it says to find the derivative in unsimplified form. So usually it'll say that if it's either hard to simplify or a yucky looking derivative. So this one is, these are chain rule questions that have more than one link. Okay. So what I want you to do first is see this as, this is my power function here. So it's that to the power of 6. Everybody good? So according to the chain rule, f prime at x is going to be 6 times whatever's in those green brackets to the 5th. That's the first link in the chain. So that's just the outer derivative. Does everyone see that's the outer, sorry, that's the outer derivative? And once we've got the outer derivative, we multiply that by the inner derivative, the derivative of what's inside, so the derivative of this. So what the issue is that to find the derivative of what's inside, it's going to involve the chain rule. This part's not. The derivative of this is 5x to the 4th. That's not bad. Plus, but when we're finding the derivative of this piece inside the bracket, that involves the chain rule. So that's going to be plus 4 times 3x squared minus 2 cubed. But then there's another link in the chain because that's the outer derivative of the orange one multiplied by the inner derivative, which is 6x. So that is the derivative. So there's a chain rule inside the chain rule.
Whoa, it's almost like it's a dream within a dream.
Right, and it can keep on going no matter how, like depending on the number of layers that you have.
Wow.
Does anyone have any questions about how to get any of these terms in here? So once you've found the derivative, you don't have to simplify it at all, but any questions on how to get any of these terms? No? Okay. If you look at B here, any idea how we would write it before we start deriving it?
You put them in brackets and put them to the 1/2 power.
Okay, so bracket x plus bracket x squared plus 1 bracket to the half bracket to the half. Okay, so again, this is my first power function. So the outer derivative, if I'm finding the derivative, my outer derivative for y prime is going to be, so this half here, half times whatever's in the green brackets to the negative 1/2. So I don't change anything in here. X plus x squared plus 1 to the half to the negative 1/2. This exponent decreased by 1 times the derivative of what's inside. Anyone want to take a try at what the derivative of what's inside would be?
I don't know. I could go for it. But,
Okay, go ahead.
Or is Carly? Do you want to say it? I guess you put your hand up, or
Yeah, if I could take a
Yeah,
stab.
yeah,
great.
go, sorry.
Yeah, just unmute yourselves. I
1/2.
can't see. Yep. What would it be?
Yeah. 1/2 multiplied by 2x plus 1.
Close. What do I do with this x here?
Doesn't it drop because it doesn't have an exponent?
It has an exponent of 1, so it's 1 times x. So the derivative of x is 1. Do you agree? Yeah. Okay. So 1
Yes.
plus, then what happens?
Would you add the 1/2?
Nope.
or-
You'd drop it down. So 1 plus 1/2.
Times x squared plus 1.
Yep. To the
power of negative 1/2
Good.
times 2x.
Good. And then our big closing bracket. Okay, so yeah, that order of operation says I would multiply, write all this before I would add the 1, and we're not simplifying anyway. So that's the unsimplified derivative. Okay. All right, so now we're on to a word problem that's going to involve the chain rule. Yesterday, I noticed a couple people did the word problem part C using first principles, but yes, yesterday you were supposed to do it using the quotient rule because that's what we were learning yesterday. So just make sure you do watch the videos, I know, and the whole thing. Try to find an example in the video that goes with one that's on the question, because really, I'm kind of just treating this as a checklist, like you're proving to me that you can do all the different things, and I've kind of got a list of all the important things that they wanted me to teach. So here's an example of and it won't always be my live video. Sometimes the examples that you have to go by will be in the recorded one. Okay, so an environmental study of a suburban community suggests the average daily level of carbon monoxide in the air can be modeled by that function, where T is the number of years from now, and C at T is the level of carbon monoxide in parts per million, ppm. What is the expected level of carbon monoxide in the community 5 years from now? So you guys are pretty good with these kind. That's just asking you, there's no rate of change there asked. So that's just asking you for C at 5. So we'll just substitute in here. All right, so 3.1 plus 0.1 times 25. So that's 0.5 times 5.6 plus 17. Square root of 19.8. So that's approximately 4.45 ppm. Is that what everyone got? Just to give you a minute to try the calculation, make sure you can get that on your calculator.
Yeah, that's what I got.
Okay, great. All right, so then let's answer our question. What is the expected level of carbon monoxide in the community 5 years from now? So therefore, expected level of carbon monoxide, is that just CO, guys?
Yeah.
Awesome. 5 years from now is 4.45 parts per million. Okay. What is the average rate of change over the first 5 years? So average rate, everyone's doing a great job with this yesterday. So some people wrote average rate, rate average, lots of different things. So first 5 years, everybody is good with that being, so it's going to be C at 5 minus C at 0 over 5 minus 0. And we just found in our first question, C at 5 was approximately 4.45 parts per million. So C at 0 is what we want to find next. So that's going to be the root of 0.5 times 3.1 plus 0.1 times 0 squared. So that's just going to make that term 0 plus 17. So that's just 0. So 0.5 times 3.1. Square root of 18.55. Approximately 4.31. So C at 5 Another thing you could do is you could leave this if you wanted C at 5 was the root of 19.8. So you could put that in like this, and C at 0 was the root of 18.55. If you want to leave your approximations till the very end. Or you can put them in as decimals and just put an approximate sign right there. Either way, you should get the same. So approximately 0.0285 parts per million per year. And everybody's really good with remembering that rates have pers in the answer. So what is the average rate? So therefore, average rate over first 5 years is 0.0285 parts per million per year. So it's growing, it's increasing because it's a positive rate of change. And now we want instantaneous rate of change of carbon monoxide level in 5 years. So what will be instantaneous rate of change? So we know that that's going to involve finding the derivative. So I'm starting off with the function that we're given, C at t. And in my rewrite step, I always want to make things as easy to take the derivative as possible for myself. So I'm not only going to write this as something to the 1/2, but I'm going to simplify under the square root sign. So here I can distribute. So 0.5 times 3.1 is 1.55 plus 0.5 times 0.1 squared, 0.1 t squared, sorry, is 0.05 t squared plus 17. Yep.
Sorry. Never mind. I thought, never mind.
All to the 1/2. And then I can collect these because they're both just numbers. So I can, still on my rewrite step, I can rewrite this as 18.55 plus 0.05 t squared all to the 1/2. So I just made it as easy as possible on me for when I find the derivative. So all I did, but like really this took me 2 steps to rewrite it and make it as easy as possible to find the derivative, which is what I'm going to do now. So C prime at t is going to be 1/2 times 18.55 plus 0.05 t squared to the negative 1/2 times the inner derivative. So the derivative of just a number is 0, but here it's going to be 2 times 0.05, which is 0.1 t. And then I'm going to write it nicely so that it's nice to sub in my number. So I'm going to have 0.1 t on top. And then 2 root 18.55 plus 0.05 t squared in the bottom. So now I'm ready to substitute 5 in. And then I can work these numbers out. So 0.1 times 5 is 0.5 over 2 times the root of 19.8. I think that's where we're going to get our final answer. So divided by, careful with putting brackets. Make sure we get the same as each other. I got approximately 0.056 parts per million per year. Anyone else get that number?
Yep.
Yep. Okay, so we need a nice therefore statement then. So therefore, instantaneous rate of change of CO at t equals 5 years is 0.056 parts per million per year. All right, so that's the chain rule. That's the last rule we're going to learn. This afternoon's lesson is challenging because we're combining the product rule and the chain rule together. And you're really going to be working on that simplified factored form. I tried to do a really good video and show all the side work and stuff, but if you're having trouble with it, please hop on the Google Meet and we can go over questions together with the camera, or send me pictures of your work in Edsby if you're not sure if you're doing it right. Okay, some of you have used that ability to pop on. You've all been doing really well, so that's great. Just make sure you watch the video this afternoon. All right, I'm gonna stop recording and get back. Hopefully it worked today. Yes, it did.